Bianca here. So I have this really cool light board, so I'm stepping up my tech game with my videos. So here we go. We're going to start with the intro to right triangle trig. So what we want to do is think about SOHCAHTOA. I'm going to write it out here. And I always put it at the top of my paper whenever I'm doing any type of right triangle trig, just so that I remember how to set up the ratio of my side lengths in reference to my angle. So let's start off with a triangle. So you have a right triangle. I'm going to draw it out. Here's my angle that I'm going to be referring to, and I'm going to call that theta. So OH and A stand for opposite, hypotenuse, and adjacent, and I'm going to label those values along this triangle right here, just kind of use as a reference. So opposite the angle that you have, so the angle that I'm talking about there is theta. If I was to draw like a dotted line across, I could do that over here. And then that would lead me to this side here, which I'm going to label as O, so O for opposite. The hypotenuse is always the longest side of your triangle, and it's also opposite my 90-degree angle. Notice the little 90-degree mark, or that little box in the corner. The corner of it is pointing to the hypotenuse, so we'll label this as our H. And then here we'll label this as A, so that is the adjacent side length to this angle, or next to. So if I'm talking about my sine, my cosine, my tangent, if I'm looking at sine is opposite over hypotenuse. So opposite the angle that you're referring to, this theta here, would be this side length O over my hypotenuse here, H. The cosine is adjacent over hypotenuse, so the adjacent side here, next to, over my H or hypotenuse. And then T for tangent is opposite over adjacent, so the opposite side here over the adjacent side, which is here. So we're going to start off pretty basic with just a triangle and setting up trig ratios, and then we'll get into how do you actually solve for angles and solve for sides moving forward. So I'm just going to erase this quickly, and I'm going to leave the SOHCAHTOA up because we're going to use that obviously to set up our trig ratios. So I also want to talk about obviously the reciprocals as well. So we have SOHCAHTOA, and we know that sine is O over A. Well, if I have sine of theta is O over A, right, opposite O over H rather. O over H. We have what's called a reciprocal trig function, and the reciprocal trig function would be the reciprocal of the fraction, just flipping it upside down. So we have sine, cosine, and tangent. We also have cosecant, secant, and then cotangent. So this would be cosecant. And cosecant is the reciprocal of sine, so just flipping this fraction upside down, you have H over A. H over O. Why am I saying my names wrong? I don't know. H over O. The cosine is A over H, and flipping that upside down, we have the reciprocal, which is secant, and that's H over A. And then lastly, we have our tangent, and tangent, remember, is O over A, and then flipping that one upside down to get the reciprocal, so that would be called our cotangent, is A over O. Okay, so those are our trig ratios. So let's look at an example. I'm going to just erase this and draw my new triangle out. All right. Okay, so we are given, for this specific problem, we are given triangle PQR, and we have angle R is 90 degrees. So we know that that's the right angle right there, angle R. We also have PQ is equal to 25, and then QR is equal to 24, and then PR is equal to 7. So let's draw this triangle out. If I sketch this triangle, it doesn't matter how you have the triangle, wherever the right angle is, I don't care. Just label it, right? We also want PQR, and it says that R is the 90-degree angle, so this is R. And PQ, place it here. So PQR. All right, so PQ we know is 25. So I'm just going to go ahead and label this as 25. PQ is 25. QR is 24, so that's this piece here, 24, and then PR is 7. So obviously the triangle, the image of it does not match the dimensions, but that's okay, it doesn't matter. So what I want to do is just set up all the different trig ratios for this problem. So we have sine, we have cosine, we have tangent, and then obviously the reciprocals as well. So we're going to start off with sine. So sine of the angle. Now the angle that we're going to be referring to here is Q, so I'm going to say sine of Q. Okay, so I'm going to label Q as theta. Alright, so now every label has to be in reference to the angle Q that's right there. So opposite is here. The hypotenuse is always along your side, so that's here, or opposite your right angle. And then your adjacent is here, so that's next to. So we have our OH and A labeled. I always advise to kind of do that first, this way you can set up your trig functions or your trig ratios. So sine of Q. So that's the opposite over the hypotenuse if we go back to the SOHCAHTOA at the top. O over H. So if I want O over H, well, O is 7, and then the hypotenuse there is 25. So 7 over 25. I could then get my cosine. So cosine of Q. Well, cosine of Q, noticing is ca. That's A over H. So the adjacent here is 24 over the hypotenuse, which is 25. So we have 24 over 25. And then lastly, we would have our tangent of Q, since that's the angle that we are still referring to. And then that would be our TOA piece, that's O over A. The opposite here is 7 over the adjacent piece, which is 24. If we want the reciprocals of these functions, remember we really want just to flip these fractions upside down. So we just have to remember, what is the reciprocal of sine? Well, the reciprocal of sine is cosecant. So we want cosecant of Q. Well, that's 25 over 7. I want the secant of Q, or the reciprocal of cosine, 25 over 24. And then I want the reciprocal of tangent, which is cotangent of Q, and that is 24 over 7. Right, just flipping those upside down. What if I was to take, let's say, a different angle? I wanted to change my angle. This time I'm going to change my angle to P. Okay. I want sine of P. Oops, it's not on the screen. You can't see it. Okay, hold on. So I want sine of P. I'll do it here. So if I want sine of P, notice that the labels are actually going to be different. So my theta is no longer going to be here at Q, so I'm going to cross that out, and my theta is now going to be here at P, so just rewriting that there. Which means my opposite of the angle is not here anymore, it's now here. So this changes to O, this changes to A, and the hypotenuse is always going to stay the same because opposite is the longest side of the triangle. So if I want sine of P, I notice that P is here. I want the opposite over the hypotenuse. Well, the opposite is 24 over the hypotenuse, which is 25. Okay, I can take any of the trig functions, doesn't matter, but notice that the labels are changing because the angle has changed.